So this evening we're really glad to welcome Rachel Chambers from the Driving the Electric Revolution. So Rachel's come to give a talk tonight. We also want to welcome everybody who's joining online. So a little bit of background about Rachel. She's been very kind and provided us with a bio, which makes my job a lot easier. So Rachel's got extensive experience of working at board level within a range of sectors and markets, including automotive, manufacturing and technology distribution. She's worked across all sizes of organisations, from large corporates to SMEs, and also set up a business. Our experience spans across working with industry, regional and national government bodies, which will become clear in a bit, academia and RTOs to develop innovative technologies, process and products. She's led the work to set up a Centre of Excellence for Sustainable Advanced Manufacturing in the North East, where she was seconded from CPI, one of the high-value manufacturing catapults, where she managed large funded projects in a business development team. Rachel is now the Chief Operating Officer for Driving the Electric Revolution Industrialisation Centre in the North East of the UK. And it supports industry to develop and scale up new power electronics machines and drive technologies and manufacturing processes. Rachel also has a wealth of experience operating as a global HR director responsible for driving innovation, commercial value and cultural change, with a big focus on equality, diversity and inclusion. Rachel left her global role to focus on bringing up her 2 children, which has enabled her to focus on driving impact in the UK, focusing on net zero and developing supply chains for the future of electrification. So over to Rachel. Thank you.
What benefit those will? Can you hear me? We're all good, right? I've just come from an event actually. In where was it? The Octagon. That was it. Talking about electrification of all things. So meeting some wonderful companies, and I think one of the speakers was here a while ago, Alan Walton from Birmingham. I don't know if anybody remembers him.
Event last year, I think you remember, on recycling magnets.
Yeah, so we've been. I was telling them I was coming here this evening. So yeah, I've got a presentation that takes you through what we're doing from a national perspective, and then what I'm doing as a regional perspective. And I know it's not quite as South Yorkshire, but it's north. We're all northerners. So I want to talk about what we're doing in the northeast as well. So I think there's some quite critical elements there, which, to be fair, are focusing on growing the manufacturing capability within the northeast and supporting them, much similar to how there's a lot going on in the Midlands, but there's not really much going on around innovation support in the northeast. So I'm trying to sort of help that. But today I'm just going to take you through what we're doing. We're calling it Derek for short. It saves my tongue. I've been talking all day. But so Driving Electric Revolution Industrialisation Centres. So just a bit of a scene setter. So we bid into some funding. So UKRI, UK Research and Innovation, back in October 2018, probably similar time I met you, and they put 80 million out there. And the idea is, as you're probably aware, is the net zero target. So I've listed them here, but effectively, as we all know, UK cars to be net zero, 2030, new aircraft by 2040, renewables with a reduction 80% CO2 by 2050, high-speed rail network to grow, no new diesels after 2040. I know there's a lot of infrastructure to sort out by then as well. That's not my area, but I appreciate that's what needs to happen. Marine transport target to be 50% CO2 reduction by 2050. Huge challenge in marine. I mean, just the colossal size and scale of the challenges that they have, that is going to be a huge challenge. And PEMD supporting Industry 4.0. So that sort of integration of digital with robotics, automation, etc. So 80 million, like I said. So we managed to win 33 million of that. And that was to establish a UK-wide network. So there are 4 centres which cover the full supply chain, and I'll talk about that in a moment. So we've got one in Scotland, in Strathclyde, the North East in Sunderland, hosted by Newcastle University, the Midlands, which is kind of a joint partnership between Warwick Manufacturing Group and Nottingham University, and South Western Wales, which is at the compound Semiconductor Catapult. And the idea is that we provide an open access facility to allow companies to prototype, develop, scale up, and effectively de-risk. So you're almost practicing in a safe environment. But the rest of the money here is really telling you that there's no more 80 million left. Government have spent that. So we're all waiting with bated breath, like everybody else, around the CSR to see whether government are going to put more money in. So to try and avoid confusion, we're called Driving the Electric Revolution Industrialisation Centres, but the government-funded initiative is called Driving the Electric Revolution Challenge. They should have really renamed them, but so we call ourselves Derek to try and differentiate. So we managed to get the funding from the challenge. They also put 2 calls out, or a number of calls, should I say. One was around 37 million. And the numbers here are actually projects as centres that we helped to bring together and do the collaboration work. So you've got Fast Start, which is like feasibility type studies, catalysing green innovation, supply chain net zero, and then we talk about skills. And I'll talk about skills later because that's a critical element to this. So why did we do it? I tell myself, why did we do this? So the reason we were creating is when you look at manufacturing process, so that's our focus here, it's not product development, it's around manufacturing process. There's a recognition that there's an awful lot of gaps and lack of capacity in the UK supply chain. So if you think of it as across the 11 sectors, you name it, anything that's around machines and drives, it's pretty much anything that you can think of there. There's a lack of UK skilled engineers, and that's even, when I was doing this 3 years ago, that's just, it's got worse. It's like hen's teeth. Low levels of UK component content in the UK's manufactured products, and a limited number of UK manufacturing process development companies from all areas of the supply chain. And some are worse than others. So if you look at renewables and energy, there's very little UK supply chain in the UK. Common technical challenges. So I've spent the last, 4 years talking to OEMs, tier 1s, tier 2s, SMEs, around the challenges that they face in this particular area, at all different levels. And these are kind of the common ones. Yeah. So you've got improved motor and drive performance. I can validate that because I've got a Tesla and I've got huge issues with my Tesla. Lots of, I need to tell Elon Musk that he needs to come and speak to me so I can help him. Efficiency, packaging, thermal management and reliability. Wideband gap semiconductors, the obvious one. Improved megawatt scale converter efficiency, the power quality and reduced motor loss, integration of motors and drives to be more compact, lightweight, design for manufacturing, for assembly and disassembly, and of course recycling, and more cost effective and flexible low volume manufacturing and assembly, and then finally digital. So the embedment of digital manufacturing, production, supply chain optimization. I mean, if you talk to any OEM, it's what they bring the cost down, it is literally all they would have want. And digital twinning as well. And that's to support sort of the low hanging fruit around predictive maintenance, but also end of life replacement. So that was the reason. And there's a few examples actually that when you start to talk to companies about where they do their testing, so this is pre what we did, they would say, well, I'd send my machine to Spain, or they'd send it to Germany to get tested because there's no capability in the UK. it's crazy. Can you imagine? So if you're a company, no matter what size you are, if you want to get your machine tested, you're having to send your engineers for a week, 2 weeks at a time to get it tested, to then bring it back to the UK. And this was ongoing. So what we ended up doing is companies were going, this is really inefficient. So actually, I'm going to just base myself in Germany. I'm going to move my manufacturing. So we're actually, as a consequence of not having anything in the UK, we were losing content from the UK. So it's kind of this vicious circle where we now need that investment back into the UK. And, you know, if you look at even electrical steels, for example, I mean, I'd love to get your feedback after this, but, you know, there's, I would say, £200–300 million worth of investment required, and it's needed because we're currently having to import it all. And it's just, you know, it's one of those situations where we're at the start of our journey to try and bring manufacturing back into the UK, but there's an awful lot more required. So, out of our 33 million of funding, 28.5 was for equipment. So that equipment was to do almost try and fill that gap that I've just described, which is to stop companies having to go outside the UK for their testing and do it inside the UK, and to develop their manufacturing capability. The vision for us is to make the UK globally recognised as the centre of excellence for power electronics machines and drives. I was asked today what makes the UK unique in this area, and I actually think it's having these centres that literally bring everybody together, which is our mission, to bring everybody together and help them. But it's to make this stuff. And importantly, when you look at our network partners, what country in the world brings everybody together with their expertise and capability and industry, with the suppliers, the manufacturers, all together and connected? So it's having that go-to place to make it really easy. So rather than going into Google and searching, I need a DC to DC converter, actually they could just give me or my colleagues a call and I can go, hey, yep, here you go, here's a list of those. And it quickens everything for them. And you're doing the work for companies, but the idea is to accelerate, because if they have to spend their time doing research, they're not really going to make the targets for the 2030. You know, they need to be looking at manufacturing and their strategy now to meet those kind of targets. So this is to really try and help demystify really where they can do that. So we have over 30 partners. I mean, you'll recognise some of these. And the regional centres basically support the clustering. So apart from having key equipment that we know that they need, we also work with companies to leverage regional and national funding. That isn't to say we have money, unfortunately, in our pockets. That would be rather lovely. But we can work with government and support companies in terms of championing what's required. And we also exploit, that sounds a bit rude, doesn't it? But we work with companies to try and accelerate, support what they're trying to do so they can then export. So we're growing their company to help them effectively feed the rest of the world. Not in all cases, clearly. We encourage inward investment as well. So we work closely with Department of Industry and Trade. For example, I'll work with the connections that we have in Singapore or China to try and encourage them to do more manufacturing in the UK. And the other key element of this is it's a real cross-sector approach. So, you know, if you think of the Leaf, that was 2013, I think that was, sounds about right, doesn't it? Yeah, 2013. So if you think of the automotive sector, they've been doing this for quite a while. If you think of milk floats, they've been going around quite a while, electric milk floats, but that technology is there. And actually that they've gone through the pains, you know, they've gone through the development and learning from that. So what we're trying to do is get them to help other sectors understand. And I think what we're here to do is try and bring those together. So where you might have, you're a classic example, you know, AEM making their motors, it's working with them to say, hey, would you consider using your motor for a marine small aircraft? And that kind of push or collection together is working slowly, but it's working. And we hope that companies like AEM and others are reaping the benefits from that. So this is, don't kill me on this, this is to represent the supply chain, power electronics and electrical machines. And when I was working with industry over the last few years, what we began to learn is if you look at high volume versus high value, it's really different. So you've got automotive, high volume with industrial drives, and high value like your renewables, marine. At the high value, it's really, you know, it's not a one size fits all. So what we had to do is, you know, we've got £28.5 million to spend on critical equipment. This was not an easy task, I can tell you. But we had to list down what the priority areas were that would best suit all of these sectors. We then chose these capability areas and tried to put them into boxes, for want of a better phrase. And what we ended up with is this, and that's really hard to see, so I'm going to have to go through it. So if we look at semiconductor production, to cover that area of the supply chain, we actually ended up with wide bandgap power electronic component pilot line. So we've got that in Wales. When you look at bonding, food frame packaging, I'll talk about the gaps in a minute. We've got ceramic and metal printing prototype facility and a power electronics reliability and failure analysis facility, which is can work across multiple sectors. We've got housing and integration, so that's the power electronics assembly line, that's actually what we've got in the northeast. And then you've got subsystem level and the system integration. Again, looking at the powertrain and accelerator and bringing that together. Electrical machines, we've got magnet materials. So production line, this is what Alan Bolton in Birmingham was looking at, which was to produce recycled sintered magnets. That capability is really significant here when we start to talk about materials. In laminations and handling, you've got high performance electrical machines, winding centre of excellence. That's predominantly based around hairpin and the auto sector. But like I said, we had 28.5 million. Actually, what we needed is, my calculations of 750 million. That's how much money we needed to fill the real void. Still minusing those, by the way, yeah? Because that in itself needs 250, 300 million. That's billions for the components, yeah? So to fill the void in totality is 750 million. We've got a long way to go. Housing and integration, electrical machine assembly line, and then you've got subsystem again in system integration, looking at the propulsion side. Here, this is obvious. Huge gap. But we didn't have enough money. And I think there's still battles in terms of the voice to government around what they're going to do to fill that void. And PCB and components. I was at a talk just before Christmas in Wales, talking about semiconductor chip shortages, what we're going to be doing. There isn't enough money from government to compete with the likes of what they do in the Far East, in Korea or whatever. We just don't have that type of money, and we can't be as competitive as them. But what we do have in the UK is specialist areas that still the auto sector and other sectors require. I think we've got 25 fabs in the UK, which I think people are aware of. It's huge. And they all look at very bespoke niche areas, but they're all critical. The chips that you get from, say, I'm trying to think how many chips there is. Something like 2,000 chips in a car. Unbelievable. And the majority come from China, Korea, etc. There's also a lot that come from the UK. It's just not widely known. So I think, do we want to fill that void? I'm not so sure it's actually sustainable for the UK, but certainly on the electrical steels, it would be. So, power electronics, okay, I'm going to try and educate you here. educate myself by doing this in the first place. But so what is it? And I think I try and simplify this, okay? So it's converting, if you think of your house, yeah, you've got your plugs, or even in here, it's converting the power from that into your device, your laptop, your telly. It's the conversion process. I'm not an engineer, yeah. But we have it in all of these applications. So it just shows you how critical it is. We had the talk today talking about battery and the investment that's going into battery, but it's almost like the world needs to be educated around power electronics, machines and drives, because a battery can't power a car on its own. It needs the stuff that we're doing. And I'm not sure that there's a realisation yet. I don't know whether you think so, Andy, but in government, when you think all the funding, it just points to battery, but not enough to this. And this is a critical element to actually making things work. And obviously meeting the net zero targets. So what's an electrical machine? I'm not trying to teach grandma to suck eggs, but for those of you who maybe aren't as aware, an electrical motor or electric generator are considered electrical machines. And effectively, you've got electrical energy, the motor converting to mechanical, or the generator, vice versa. And there's different varieties of machines as well. I don't know if I've got a picture of yours up there, have I? So these are just to give you an example of the different types. And they all require a different drive strategy. So you've got some with no magnets, mainly around sustainability, but you'll get others who don't want to entertain that yet. And so they still want to maintain with the magnets as well. And then we get into electrical drives. So an electrical drive is a system that combines basically the motor, the power converter, and the control. And it also dictates the speed as well. And a typical drive system is assembled with an electric motor, a control system, and that controls the rotation of the motor shaft. I'm making it really simple. I can share these slides afterwards as well, can't I? Yeah. So we're here really to support partners across that full supply chain, looking at prototype development, processes and scale up. So we take what is done typically in universities at research level. We're right up here, we're in commercial industrialization level. So we're kind of living and breathing with industry. We're not going to, we don't keep IP, that's there for individuals, but this is about manufacturing process. So if we can reduce costs and provide efficiencies in whatever way that we can, we will do that. And effectively that's to get to all these targets. So this is just giving you the locations of where the equipment is. The equipment is based around the expertise that sits in those regions. So you can see it spans considerably across the UK. So just to give you, I know I went through the equipment before, but I'll go through it again. So in Newcastle, or in Sunderland really, but hosted by Newcastle, we've got an assembly line for power electronics, and we've got electric machines assembly lines. So when you take the stator, the rotor, chemical dispensing, end line testing, we will do that. It's high up the supply chain end. In Nottingham, they've got the magnetic test characterization, power electronics reliability at Warwick, the winding centre of excellence at Warwick Manufacturing Group as well. Wideband gap power electronics, so that's to look at the next technology. Obviously, we recognise around silicon and the materials there, but when we start to look at silicon carbide and we look at gallium nitride and the efficiencies that we can get with those, that's really about testing that. I mean, I think we all recognise that silicon is not going to go away. We're not just going to replace it. I think there's going to be a few more companies that need to test it and want to validate that. But what we do know is when you look at the materials in silicon carbide and gallium nitride, there's more efficiencies that you can get from that. Again, looked into the catapult, we've got prototype ceramics, sub-assemblies for integrated power electronic modules. Birmingham is the rare earth magnet recycling. And then in Scotland, I always say they do the big stuff. It's megawatt scale. They typically support most of the big motors, so like naval vessels, aerospace. They do very little with automotive, but to be fair, that's kind of fed through all the other locations that we've got. Okay, so I'm going to give you a bit of an overview of what we're doing in the Northeast. So back in 2017-18, I was working for one of the catapults. I got the opportunity, there was kind of a cohort of organisations, universities, trade bodies, Nissan with some of their supply chain, wanting to build an innovation centre for manufacturing in the Northeast. So like you have AMRC here, we wanted an AMRC of the Northeast. Fair enough. And at the time as well, there was an international advanced manufacturing park that was being created through Sunderland Council and South Tyneside Council. So again, similar to how AMRC, if you think back 20-ish years when it was basically just a slag heap, I think, wasn't it? There was hardly anything there. And you look now the infrastructure where you've got hotels, supermarkets, you've got Nikon, Boeing, you know, it's huge. And we wanted to kind of have that for the Northeast, because what we recognised is that when you run a manufacturing facility, you don't want to be sending your engineers miles away to do the prototyping and the development, and they just can't afford the time. So having something on your doorstep is actually quite critical. So I set off to do that, and COVID hit. I'd built my facility. It was a beautiful brand new building, and it became a Nightingale hospital. So yeah, £20 million worth of investment, all planned and bespoke. Honestly, every time I go past it, it's like a knife to the heart. But we also hit lucky in some way, because through COVID, this building came for sale. So this is actually opposite my main building, so I have to go past it every day. This site is near the Nissan factory in Sunderland, and Sunderland Council had funded the 20 million for the original building, but when it became a Nightingale hospital, they then bought this for me. Not just for me, it was very kind of what they did, but obviously for industry. And it was about 3 million, and they've also built a clean room, put all the M&E in, and made it a fit-for-purpose facility, which is absolutely amazing. I think that's probably more tantamount to the support that you get in that region, and actually recognising how critical infrastructure this is. We also got quite a lot of in-kind gifted equipment as well from industry, from manufacturers who recognise the need to do this and help accelerate it. And we got funding as well for 5G. So when you look at wireless infrastructure, what this does is it allows us to play a little bit as well and look at the I suppose the benefits of 5G and actually how industry can, rather than having to pay for 5G and not really understand what it's going to do, they actually get to test it in our facility, which is pretty cool as well. So that's our equipment with power electronics, and then, like I said, with the assembly line. And it's to try and support end-to-end manufacture. We also have, to benefit from 5G, the digital support, the analytics. So really getting as much data as you can from your manufacturing process to drive costs down. And then digital twin as well. So what that means is that we can be with a company in the Midlands, we can effectively duplicate what we're doing without actually having to be there. It's quite cool. I should have put a video on here really, but I can send one when I send the slides out, so you can see what can be what's capable. So the 5G is really there to support the innovation in the process and to rapidly reconfigure and retool assembly lines. So if you think of, say, a Nissan, the obvious one, it means that they can react well, preempt more than anything, but react quicker. They've got data at the fingertips, which means that they can do things and change things a lot quicker. It also helps the collaboration. So we talk about robots. Robots are great in isolation, but actually when you're doing a manufacturing or assembly line, it's actually also great to do it collaboration with human and robot. And this allows you to look at that and look at how you can increase productivity and efficiency. And I suppose it is that continuous element around driving operational efficiency for people. Impact for the North East. So this is just to give you a sense of the funding that is actually currently available, which is, it seems quite a lot, but the whole of the UK are bidding into this type of money. So Driving the Electric Revolution Challenge has £1 million left in which we're bidding into. That's to do with skills. So the idea is it creates flexible curriculum to support upskilling and reskilling of engineers. So as we know, we've got a massive shortage at the moment, but actually if you had a mechanical engineer, this is a crude example, but if you had a mechanical engineer and you could invest in the skills that are required to make them more electrical focused, it's that kind of thing that we're trying to do. Or even anybody who is technical and trying to upskill them, it might take a little bit longer, but it's trying to find quick and flexible ways to build that workforce to support the electrification journey. Space is another area. If you think of satellites, drones, all of that, there's a lot of money available there. And in marine as well, I think there's a recognition that there's been a bit of a drought for quite some time in this, and there's a big focus. So my job is to work with industry and understand their challenges and understand where their gaps are, and then work with them to bring those companies who can fulfill those gaps, then try and exploit some of this funding. And it's a bit of a bidding war. I mean, it's like when you apply for funding, it's about what, a 1 in 4 chance, do you think? You say? For most of them, yeah. You've got to be quite skilled at writing these bids as well. And then we look at foreign direct investment. I mean, in the Northeast, I'm currently working with a Chinese company because they want a footprint in the UK. They want to manufacture in the UK, and it's current capability that we don't have. So I'm working with them to get them to have a footprint in my facility so they can kind of test the waters, so to speak, before they hopefully spend multi-millions of building a manufacturing facility. And the UK, I mean, I set off talking originally about the vision of making it a the global place to come to. This is poking interest. So we've got a lot of companies in Poland, Italy and Germany starting to get interested now in coming to the Northeast, because you've got a colossal amount of expertise. You know, if you think of, AEM's an example, but there is an awful lot of companies doing stuff around electrification, whether it's machines, whether it's the DC to DC converters, whatever it is, there is an awful lot in the Northeast focused on that. And there's also universities that have amazing capability. I mean, Newcastle Uni, who would have known it was world class in electrical machines? And they've got a centre of excellence for Dyson. Unfortunately, Dyson don't manufacture here, but nevertheless, they do a lot of work with the university because they know where the expertise is. And when we talk about research in the UK, believe it or not, we are globally recognised as being the best in terms of our research capability, which is why we really started this journey. So the US are great, don't get me wrong, and they publish loads of papers. China are amazing at publishing papers, but the quality is not that great. The quality of what we produce, it far outweighs them. And I think that's something we need to hold on to and develop by having centres like we do. And when it comes to skills, I think that's something that we've talked about in depth today. And in fact, every conversation I have, whether it's STEM, so whether going into schools and talking to them at an early age to try and get them interested in engineering. There's an awful lot of work that still needs to be done there. I think even with the Education Authority as well. I was talking to a student, 15, 16-year-old, and I said, what does engineering mean to you? Or what do you do in school around engineering? And they did welding. So they used a welder on a bit of metal. And I was just absolutely flabbergasted. I mean, how is that inspiring? I mean, I did that, and I'm a lot older than her. But it really shocked me that, you know, it was just before COVID, so it wasn't long ago. But if that's the kind of education children are getting, why would you want a career in engineering? But engineering is pretty cool. And when you think of the digital element and that whole automation, autonomous, you know, all the stuff and the art of the possible. I mean, it's Elon Musk. I mean, you know, you watch some of his videos, people might think he's crazy, but you know, it is the future, whether we like it or not. He's already doing it. And I think it's inspiring children at that age, but it's also trying to fix the problem now and encouraging employers to bring on more students, but encouraging employers to invest more as well in terms of skills. I mean, the market is a really challenging area at the moment. You know, whatever you paid for an engineer 2 years ago, you're paying premium maybe 20 to 30% more, because there's a recognition that there's a shortage. So it's a bit like the housing market. It's as crazy as that at the moment with engineers. I only need 2, by the way, and I'm going to struggle. I know that already. But to give you an example of the shortage, in the Northeast alone, there's a shortage of 13,000 per year of engineers and related technical skills, just in the Northeast. It's about 230,000 UK-wide every year. Where they're going to come from? And that has to be then investment for training and skills by government to support that. And those skills aren't just in P&D, you know, they're across battery and that sort of resolve around there. So I think there's any help you can give me, by the way, on this, any help you can give industry, because it's a huge issue. And it's almost like you're trying to fight the battle to meet these targets, yet we haven't got the engineers, the number of engineers to actually help that process along. So there has to be more investment in terms of skills. We're on that journey. And I mean, in the Northeast alone, we're looking at trying to bring a cohort of all the colleges and the universities together to support what industry need. And a lot of that is around flexible learning. You know, I mean, who would have thought you could put a VR headset on and start to actually teach somebody how to be an electrical engineer? And it's those kind of creative and innovative ways that we're having to do in order to fulfill that, because you can't now take engineers out of their workplace for 2 or 3 days to do a course because they can't afford the time out of work. So it's a real, you know, chicken and egg situation that we're in, but it needs more investment. So that's really me. I did actually steal a slide. I'll show you anyway. I don't know if anybody remembers this. So Alan Walton gave me this afternoon, because I thought, I'm coming here with gurus from the sector of materials and engineering. And I said to him, I said, what's your sort of takeaway when you look at materials? And I kind of, you know, we've got 12 areas there, and we looked at trying to encourage recycling and refining. So when we look at sort of rare earth materials, there has to be a focus on what do we do with it. And one of the challenges that we have at the moment is we actually don't know the size of the issue. So if you're recycling magnets, how many companies in the UK get rid of their waste? There's just no monitoring of that. And that's quite interesting, really, because then you don't know the size of the prize if you don't know the size of what you're dealing with. So that's something that Alan's working with. Now, Alan, or Birmingham University, is part of our network. So we work closely with him as well to try and support some of the stuff that he's doing. So he's let me steal this. I'm just flagging that. I haven't nicked it in 10 minutes time. And then we look at the supply chain as well around designers and looking at schemes around batteries. So I might focus on power electronic machines and drives, but I can't have a conversation without talking to somebody about the energy source that they want to use. That would just be silly. It's like a marriage. A car needs to power up and do something. So we also work with people around the system integration. So if it's power electronics, clearly you need that to support with the battery. But if you're talking to marine, it could be anything from hydrogen to synthetics or whatever it might be. So we do work with lots of different companies. We're starting to also work across complementary, I'll call it, technologies as well. So whether it's additive manufacturing, there's 3D printing, loads of different innovations that we're starting to look at and embed within our North East facility, as well as across the UK. So it's kind of the start of the journey. I mean, the centres aren't actually fully operational yet. We've got lots of projects, by the way, and we're ready to press the button. So we should be opening around June time. I will extend the invite when we have our opening. We've got the Midlands there looking at probably midsummer. In Scotland, it's not going to be until Jan-Feb 2023. A lot of what they're doing is quite long lead items and bespoke. In Wales, they're 50% there. They've got some operational and some that will be coming online very soon. But I think I'd like to probably come back in 2 years' time and tell you what impact we've made and see if the North East is starting to get a little bit bigger and rise like the sort of AMRC for here is doing. So that's me. Thank you very much. We do. Siemens actually do a lot in the UK. So they've got a big drive centre in Manchester. And ABB, you can't get away from the fact they're established. I was talking to a company today that said, well, we get all our motors from China. They don't want to. And what they're trying to do is establish actually ways of not having to get motors from China for obvious reasons. So I'm working with her to try and understand actually where can we get companies in the UK to manufacture cost effectively motors. So some of the challenges that we face here is we're not the size of ABB and Siemens, a lot of the manufacturers of drives. So there was a company I spoke to that said, look, I've got, let's say, low to medium volume, 10,000 units a year, wouldn't entertain it. They want hundreds of thousands because it's not cost effective for them. So what we're trying to do is, if you work across multiple people and say, okay, that one's got 10, that one's got 10, we can bring all of them together. We might have a compelling case, but there's these challenges that we're trying to work through. I mean, we're only early doors. When you think about, we're not even live yet, but when you start to think about the funding that government have made available, it's really only been going on for the last couple of years properly to cover all the sectors. So I think it's early stages. We will have to be reliant upon getting motors from outside the UK for now. But honestly, I am absolutely positive that we can start to be a little bit more sovereign capability for the UK and be a bit more self-sufficient. I don't think you're ever going to be there 100% just because it can be done so much cheaper. But I think ideally we would like to get a big chunk of that within the UK. I don't know if that's has that answered your question?
So I'm just wondering if you had any links with them because they do want to do that.
They do. So I work with Siemens personally on the digital side, but I've got colleagues who work with them on the renewables. So like the Siemens Gamesa over in, is that Grimsby? I think it's Hull. So yeah, there's a lot of work they do to support the UK manufacturer as well. We're also using digital technologies, which we've managed to get for free from Siemens, to support companies who come into our centre. So as much as they're global or they're German based, they do a lot in the UK, and that's fine. I don't mind that. So it's not really in my power to mind or not mind, but you know, the idea is that we would prefer them to manufacture more in the UK because that builds jobs, it supports industry in the UK. But we need their capability. You know, ABB are amazing at what they do. So we will continue to buy from them where possible because they can support what we need to do in terms of manufacturing. So I think that if you look at the Department of Education, I think need to put a mirror up. Unfortunately, I'm not responsible for skills in that way. But what I have seen is a bit like you saw in the digital era. So when I was working in industry back in 2006 and 8, we had a similar issue with digital. Everybody was wanting the best iPhones, the laptops, the iPads, everything, and digital just went crazy. This is actually worse because government has set policies. So the panic button's on. Everybody needs to meet these targets. And you can't magic engineers. The challenge with engineers is it takes 3 or 4 years to do your degree, and you can't just do that. So I think if you, there is no magic wand. I think, you know, if we didn't have the government policies, you wouldn't be in this situation. I honestly don't believe you would be. And I'm not saying that's right or wrong, but what it's doing is it's making people realise that all sectors have to meet these targets. That means that you have to work quicker, do more around electrification, and there just isn't the amount of students coming out of university that are getting pumped out of university to meet that. So you've also got the other challenge is that colleges and universities compete with each other. So you've got courses coming out of your ears, but actually none of them, or very few of them, are actually being able to meet what industry need. So industry need it quick, they need to be flexible, which means often when they're flexible, they need to be much more online based, or like I said, VR capability and technologies. Again, they're all having, the digital side needs to accelerate. So there's lots of courses, there's some that aren't specific enough or that meet the requirements of industry because they can't afford to take people out. So I think there is not a magic solution with skills. And I think the Department of Education need to have a look at how they fund and work in a collaborative manner. We're kind of doing it in isolation, really. I think the universities who are involved in electrification, like your Warwicks, your Nottinghams, your Sheffields and Newcastle, they're all sort of sat there going, well, we're going to do it. We're going to get off our seats and we're going to have to help industry, because the way that the current curriculum works is not doing it quick enough. So in terms of the original one, the prioritisation was done in a staged format. So we had to look at it in terms of what was going to benefit more sectors, also the critical elements. So what are the critical elements that are going to support the real push for power electronic machines and drives? It took a long time. There was independent assessors, internal, external, went through 3 tranches. So I'm not sure if we get it right, but you've got to go through, you know, the sort of processes that we went through. Love the question around the investment. Not enough. There is not enough investment in PEMD versus battery. Nowhere near enough. And I think that's starting to resonate a little bit with government. If you think of the hundreds of, I'm talking hundreds of millions. So the Faraday is almost the battery funded element, whereas we are the DER challenge. I dread to think there must be 250 million plus. You think what they've had? We've had 80. I think, in fact, I think they probably have double that and continue to do so. So I think we're kind of using that as a mechanism to say, come on, you can't have one without the other. And equally, batteries, you know, absolutely, they're investing in the UK with the gigafactories, but they need to put the same amount of investment into this as well. And we work hard, you know, the guys in Innovate and us, we work together to try and provide that intel to sort of get them to understand what's needed. But there's only so much you can do with government, as we all know.
Is that the difference between bringing in a big fancy new building from a zero base and the difficulty in investing in a lot of small SMEs who we're trying to develop products like the power machine products? Well,
It's an interesting one because we don't need buildings effectively. The North East is slightly separate. That's been an investment from a regional fund, but the other facilities were already existing. But that 20-odd million has purely gone on equipment. And I think, like I said to you, we need 750 million, probably more than that now, to really truly fill that void. So we continually try and knock on the doors of government to say, what's the next tranche? So I will be looking forward to the results of the CSR to see if they've heard us.
So I'd like to say thank you very much. I think really interesting review of the work of the Derrick Centres. And really appreciate you coming here to speak to us today and to give us a really great overview of all that activity that's going on. Great to see it being done here, being done with a strategic view of how to achieve those really challenging goals of taking combustion engines out of the circulation by 2030, 2040, 2050. So I think really great to see that there are concrete things happening and centres being built and projects being put in place with real government funding to try and help bring those things back. So very much, I'd like everyone to join me in thanking you for your presentation.